Sandeep is a committer and also the PMC in the Apache Knox project. So if you have any questions regarding security or the security gateway, please have them ready. And we have the knowledge repository with us in human form. Once we get to the Q&A part, please feel free to ask your questions. So over to you, Sandeep. Thanks for your time again.
Well, thank you so much. Thank you for the introduction. So, basically, introduction. And so I'm at Cloudera, as I mentioned, a committer and a PMC member for Apache Knox. I've been involved with Knox since 2016. That's when I started contributing to Knox, and then eventually became a committer and a PMC member. I'm also a committer for a project called Apache Org, and I do some other open source contributions which are not under Apache Foundation. If you want to connect, my Twitter or X or GitHub handle, and email address. And if you want to commit to, are interested in committing or being the contributor or committer to Apache Knox repo, or for that matter, any Apache project, let me know. Let us know. We would love to talk to you, help you out. It's a community effort, and we encourage the community to to contribute, and that's how we go. That's how we all go. So, standard disclaimer about the slide deck and today's agenda. So we'll talk about brief introduction to Knox, an overview of Knox, I think so defense, where Knox lies in the whole architecture, some key Knox concepts, and then we'll dive into Webshell. Hopefully, my demo would work, and then we'd go to question and answers. This is I would like to keep this more fluid. So if you have any questions, feel free to ask the questions on the chat, and I'll try to answer them as I get them. Trying to see if I can pull up the chat here. But yeah,
we'll help you with that, Sandeep. No worries.
Yeah, cool. If anybody wants to explore any of these topics more, I think we have some time. So let me know if you want me to go do a deep dive into topics, because there's so many different concepts and so many different things that we can go deeper into. So Apache Knox. This is a brief history of Knox. We started as a project, as an incubator project in 2013, initially as a Hadoop gateway. So Knox was an entry point into Hadoop services. The idea was, since Hadoop has Kerberos, and not everybody is comfortable or has access to Kerberos, or it was tedious to set up Kerberos. So the idea of Knox was to help users access Hadoop services using REST APIs. So Knox takes care of all the Kerberos part, all the security part, and users could just make a REST API call to the Hadoop services. Then it grew into the UI part, where we started incorporating proxying UIs. So then we started, proxying complicated UIs such as Ambari and Cloudera Manager, and then Hue. Now we do Zeppelin, and there's a whole bunch of other UIs that we proxy now. And it's just not limited to Hadoop ecosystem. We proxy UIs for a lot of other projects. So in October 2013, we went into an incubator release. Then it took us 2014, we graduated into an Apache top-level project. And then it took us about 4 years to release 1.0. So we released Knox 1.0 in Feb 2018. And then recently in February of 2013, we released Knox 2.0. If you look at the timeline, it took us about more than a year to work on 2.0 and release it. So 2.0 was a major, it was a big community effort. We had to do a lot of rewrite. A lot of code was rewritten. Packages structures were changed. We moved from log, log4j1 to log4j2, a bunch of security fixes, and a lot of exciting features like Webshell is in 2.0. So that's why it took us a lot of time to get all these features reviewed. We had to think about the security implications. We had to put the design out and let the community respond and comment, critique on the features. So that's why it took us that much amount of time. But now that it's done, we're working on the 2.1 release. So exciting times. This is a brief overview of Knox, very high level overview of what Knox does. So we have we have authentication services. So you can authenticate using Knox. So we have a whole bunch of authentication and authorization providers like WebSSO, SAML, token-based authentication, OAuth, LDAP. That's too many to name. And then we support a bunch of proxying services that are supported out of the box, like Uzi, WebHDFS, Phoenix, Zeppelin, and a whole bunch of proxying services. And this is and it's really easy to write proxy support for Knox. We have some good documentation online. Then we also have SDKs and client DSLs. So we have a GUI-based DSL called Knox Shell, which you can connect to. So basically, you can use a command line shell to connect to the Knox instance and basically run your commands from your local client machine. We also have an SDK which you can use to write your own plugins. So we have a lot of teams writing their own plugins. Knox has a very pluggable architecture. So you can write your own authentication provider. You can write your own authorization providers. You can everything that we have in Knox can be extended, and basically like, anything can be extended. And the idea is even when you upgrade Knox, that support is not broken. That's why, I mean, unless you go from 1.0 to 2.0, there might be some breakages, but unless you move from major releases, that support is still, if you build based on SDKs, your plugins would still work. In fact, one of the things that we did moving from 1.0 to 2.0 is we changed the package structure. So we changed it from, I forget what it was, but we changed it to org.knox. And there was some breakage, but we have backwards compatibility so that even if you have older scripts or older SDKs, they still work. So we try to make sure that things are backwards compatible. We try to take the best effort to make sure everything's working. And if there's something is not working, then we try to fix it. So if something's not working, then it's probably we don't know about it and we would like to know. So if you encounter an issue, please send us an email on the mailing list. I'll get to the mailing list at the end of the presentation. Rings of defense. So basically, where does Knox fit in? So if you have your cluster running, or a set of services running in data lake, or it could be in cloud, it could be on-prem. But basically, these are the rings of defenses. So Knox just Knox will not provide you security. Knox is an addition to your security framework. It's think of Knox as a additional addition to your security, and not just like the de facto security. So Knox sits at the edge of your cluster, at the firewall, and after Knox comes your authentication mechanism. So you have your Kerberos LDAP, or whichever authentication mechanism you choose to use. Knox will work with that. And then you have your authorization. You can use ACLs. Knox is a concept of ACLs, which I'll get to later on in the presentation. But we can also use arranger authorizations. So which means you can write your plugins, write your authorization as a ranger policy, and Knox will enforce that. Then comes your operating system security, which is accesses such as users and who can run what commands. Apache Knox, you cannot run Knox as a root. This is for security because Knox does because we don't want to run as a root and have all access. So if you try to run Knox as a root, it will fail, and it will give you a message saying that you cannot run Knox as a root. Then comes your final data protection, which is on S3 or ADLS2. You have disk level encryption, which is your data at rest is encrypted. That is basically making sure that whatever data is on the disk is encrypted, and it doesn't, that there's no, if somebody gets to the data, there's no issues with that. So these are all the different security considerations that you need to think about. Now let's talk about key Knox concepts. So these are just basic Knox concepts. There are more, but these are just, if you're just starting out with Knox, these are the things that you need to know. The most important one is the topologies, and arguably the most important thing is it's a Knox topologies. Knox topologies are a set of XML files historically. Now we have JSON files which you can plug in. You can use JSON files or you can use XML files. So what Knox topologies are is basically it's think of it as a set of services and configuration for those services, what authentication you'll be using, what authorization you'll be using, how those services would be used. Will they be HA? Will they use load balancing? Will they use sticky sessions? All of these configuration settings are defined for those services, are defined in a Knox topology. So a topology consists of which services to proxy. Do you want to proxy Zeppelin, Hue, Hive, etc., and how those services will be proxied? Will they be using HA? Or will they be using load balancers, or will they be using sticky sessions? Those configuration. Then your topology gives you a unique URL per topology. So in this example, you have the Knox host port, and the gateway part is the name of your Knox instance, which can be changed. Default is gateway, and then you have your topology name and the name of the service. So the way you can use a topology is you can have, let's say you have multiple clusters. So you have a dev cluster and you have a prod cluster. You can have a dev topology and a prod topology. Or your dev topology, you can have your dev authentication where you authenticate using your dev credentials. For the prod topology, you could have authentication based on your production credentials. And then you could have your own authorizations and all based on those two topologies. So you could have different set of topologies with different services. It's all, you can just mix and match however you want it to be. It's a nice logical. Knox gives you way to logically separate a set of services based on their access patterns. So yeah, like different access requirements you could have like different access requirements for the same cluster. So you could have for the same cluster, you can have multiple topologies that define different authentication mechanisms. Like you could have a topology that you could use to access the services based on SSO using single sign-on. On the other topology, you could access them using tokens, like header-based tokens. Or on the other, you could have another topology which you could use PAM authentication or LDAP authentication to access those services. So that's the benefit of using different topologies, so that you can logically organize your services. And a topology consists of different parts: authentication, authorization, services, and applications. These are the main parts. These are the main parts of a topology. And I'll show you an example of a Knox topology at the end when we get to the demo. And I can show you how a topology looks so you have a better understanding. I just don't want to put some code in the slides. It just confuses, in my opinion. So, but a topology has authentication, authorization, services, and application. And all of these can be are modular. By modular, I mean you can choose from any authentication provider. So Knox is a bunch of authentication providers that you can use. We have LDAP, we have OIDC, we have Kerberos, Benego, we have token-based, we have header-based auths, we have PAM. There's a whole bunch of authentication mechanisms, SAML, that you can choose from, that you can plug and play. So you can use any forms of this authentication can be used. The only constraint currently we have is you can only use one authentication. So you cannot combine two authentications. Like you cannot use, say, SAML and LDAP, or SAML or LDAP. So that part is, we're still trying to figure that out. With authorization, you could use that. So we have a couple of, we have a bunch of authorization providers. We have ACLs on, wherein you can define ACLs on a service, based on a service. You can say that a service can be accessed based on a user, groups, or an IP address. You can also define authorization policies based on your Ranger policies. So you can set your policies in Ranger, and Knox will pick it up from those Ranger policies. And these authorizations are and or, and you can mix and match them. So yeah, we added this support recently in authorization, and we are thinking about adding it in authentication, but it's a little tricky. So that's why it's still in the works. And then we have services, and these services would be your services like could be Zeppelin, Hue, Solar, and all these different types of services. You can add your own service, you can remove service. That's completely up to you which services you want to be exposed as a part of topology. And then Knox also had a concept of applications. So applications are services that are built into Knox. And when I say that are built into Knox, these are, an example would be admin UI. So Knox has its own UI. So you just run, Knox comes up as a bundled jar file, and you just run the jar file, and it has its own UI. So that is an application in itself. So like I said, Knox is very modular. So we have these logical things. So if you want to add your own UI, or you want to customize your own UI, you have the application endpoints. You can just extend those, and you can write your own UIs and just plug it into Knox and just works. So you take your web app, put it in the web, a specific directory in Knox, and it'll pick it up from there. So admin UI, Knox SSO, Knox token. These are a few examples of applications that are shipped out that come out of the box with Knox. Okay, so Knox Webshell. So what is Webshell, and why do we need it? So one of the things we noticed was with Knox, and it's especially with the clusters moving to cloud, was users were finding it difficult to access the cluster. So if you have to access a cluster, you have to access a machine in cloud, an admin has to share the keys with the user, and then eventually what would happen is that key would get shared multiple times, and then it'd be just one key for like a whole team of people using it. So there would be really no security there. Anybody could access, anybody would do, could access the cluster. There would be no audits. There would be no, basically there would be no traces of who did what. And on top of that, if you have users like a data scientist who just wants to access a cluster, but who doesn't, it's difficult for them to SSH into a bastion node and and then access a cluster. It just gets too complicated for them. Just access a cluster to run a job. So this was one of the motivations for creating this feature. So what this the simple few use cases are accessing logs. So let's say you want to access logs, and this can be Knox logs. It could be any other logs. You could just go to the terminal using your single sign-on and access logs. If you want to run jobs, you could just log into the using your single sign-on, log into the Knox UI and just run your jobs like you run on a machine. And the main advantage here is that you use single sign-on. You don't have to use any extra credentials, and you use your enterprise credentials, which means the network admin or whoever is configuring those credentials, they have more control over who they can let in. For example, if a data scientist needs access to specific commands, that can be tweaked. Or if an admin needs more controls or more access, that can be granted to them based on their goals. So you can give very fine level access to users based on this system. So that's and it's just basically click and you get into the shell. You don't have to you don't have to log in into the terminal. There's no tunnels. There's no port opening. So there's the security impact is extremely less here. Like I talked about, we have fine-grained controls, so we can access your source, controls on what jobs you can run, and you can also grant fine-grained access based on which directories the users can access. Basically, you can have them access only a subset of directories on the machine, or you can have them give them access to whole, all the commands and the whole root access. So up to the admin. So use cases, SSO to access log files. Like I said, one of the issues that we were running into is debug logging. So when there was a failure on a machine, you need to get to the exact logs to see what happened. So getting those logs right now was tricky because we had to go ask the customers to upload the log into a system. So with this, it was tricky for that. Like if you have to ask a customer to log into the machine, to SSH into a machine and get the logs. So depending on the different teams, it was problematic for them to get access. Every team that has to get admin access and try to get to the machine, get the logs, download it, upload it to somewhere else so that we can look. With this case, you can just jump on the call, and they would, based on their SSO access, just log into the machine, look at the logs, and the best part is they could analyze the failures themselves, and see if there's something that they can do, or else we could fix it. So the time to fixing issues was drastically reduced because of that. Easily get the logs, easily get to the debug logs. So that was a major advantage. SSO access to CLI. So if you have to run Spark jobs, right now you have to go open a terminal and then run a Spark job. I mean, if you want to use a command line CLI to run a job. In this case, you just choose your enterprise credentials, log onto a machine, and run the jobs, CLI jobs. Or if you just want to access other services within the cluster, other services which are not exposed, you could just go to the command line and then ping those services, just access those APIs from within the cluster, from inside a firewall. And so what are the security considerations that we have to take into account for this? So we, some of the things we thought about is session termination after user inactivity. So if you have, I mean, this is a terminal, right? It cannot be open for a longer time. Somebody walks away from their machine. If the terminal is running, then that's a security issue. So what happens is the session is logged out after X amount of configurable time. So the session gets terminated, and then the user has to open the new session again, and then they can log it, and then they can stop to do what they were doing. And logging is configured to prevent logging of sensitive information. This is basically the audit log. So everything that you do in Knox is audited. All the commands are audited. By default, the commands right now out of the box are turned off because a lot of the times what we noticed is users log into the machine and using something like knet, or they might use passwords on the command line, and then those passwords will be logged into the log file. And once the password gets into the log file, then you have a compliance issue. So out of the box, it's turned off. You can turn it on if you understand all the complications, all the implications of logging these things. It can be turned on. We're still working on a feature where it can be masked. We still haven't gotten that to that point because if you want to mask if you want to mask the passwords, then you would have to be listening for those patterns and those commands. And right now we don't want to. We have to think about how we can do that securely without losing the speed and without causing inconvenience to the user. So right now it's a Boolean option. You can turn it on or you can turn it off. The sudo-rs file can be configured to allow or deny access. So you could have for the web shell to work, somebody has to, or an admin has to explicitly grant access to the user to be able to use this feature. So there are guardrails against who is given access for this feature. So the first thing is, out of the box, the feature is turned off. So you have to turn it on, and once you turn it on, you have to do some additional configurations based on to allow a specific user or a group of users to access the resources. So this is to prevent anybody from having a complete access of the system. So a network admin or an admin is involved in this process. So they have to explicitly grant access to users or a group, saying that, okay, I'm letting these users have access to these resources, these commands, these directories. And we also have an ability to configure the concurrent sessions. So right now, one of the things we noticed is a lot of people start not to a single point of entry to your cluster, which means everybody was trying to open the Webshell sessions goes through Knox, and these sessions are expensive in terms of memory. So there is a chance that you could take the system down, which means it's down for everyone, and you would get into the a denial of service or quality of service type of issues. So that's why out of the box, the number of sessions that we allow is, I believe it's 20 or 25, but it can be configured based on how you run Knox. I mean, if you give Knox more memory, you can have more concurrent sessions. But it's extremely configurable what you can do. Okay, so let's see if my demo here works. So I already have Knox running, and let me see if now let me do this. Start a new session. All right. So at this, I have Knox running, Apache Knox running on my local machine. I just downloaded it from Apache Knox site. We go there to knox.apache.org, and we have releases. And I just downloaded Knox 2.0 and configured it. And if you see, it's running locally on my machine. And I'm going to the homepage, Knox homepage, which is again, it's a type of application. It's not a service that Knox is proxying, but it's a built-in application within Knox itself. So since it's a local instance, it's a self-signed cert, asking me for site issues, and I have configured a user Knox, and I've given access to the user Knox here. So I'm going to log in with that Knox user. And for authentication, I'm using local LDAP. So Knox also comes with a demo LDAP, which you can use for testing. So see, I'm logged in as a user Knox, and the user Knox doesn't have many permissions. It doesn't have admin access. It has basic access, but I have in this Webshell on, so you can see the I have a URL to access Webshell. So if I click on that, it drops me into the shell. So yeah, right now my Knox user permissions on Mac are not. I have to figure out how to do this. But on Mac, it's kind of flaky, but it still works. You can see I'm logged in as a user Knox, and I do who am I? You see Knox. When I log in, I get dropped into the user Knox directory, into its home, into the user home, and basically I'm just able to run the commands just like I would be running on on a terminal. And the fun thing is we could actually do VI. This took us a lot of time to get it working right. Because if you see in VI, you use different keyboard commands like control and all, and the control options. For example, like getting into the insert mode. So notice it works with all the controls, character, and escape character. So it's just a terminal, just like any other terminal. You could do everything you could do with this. Let's try to see if I can access there. Not yet. So go back and go. Exit. So my connection is closed. So so this is so that was Webshell. So let's talk about the Knox topology. So we have different topologies in Knox. Right now, and these are different services, but notice we don't see any topologies. This is because my user doesn't have permissions to look at the topology. So let me log out and log back in again with a admin user. Log in as admin. Oh, I was just logging, and then I can show. What I'm showing here is I was just stealing the logs, and this is an example of Knox audit logs. You can see the Webshell process, the user Knox, and this is the process that Knox started. Success. You can see the bash process was started and the bash process was terminated. So you have the audit logs for that. We also have detailed logs about what was done, who logged in, and what different resources they try to access. So these are all the audit logs that Knox has, which basically keep tracks of who logged in, at what time, and what permissions and groups they have, and all those fun things you need. Let's go back. Let's go to the admin UI, Knox admin UI. And here, let's look at the topology. So this is an example of a topology. So here you can see that, earlier I talked about different providers. So we have an authentication provider here. So right now it's, and this is a sandbox topology. And this is authentication provider, and it's configured to use LDAP. So right now it's going at my local host, the LDAP that's configured locally. So it's using the locally configured LDAP. And this is a identity assertion provider where you can assert an identity of a user. So right now it's default true, which basically says an admin identity is admin. You could also assert a different identity. And there are different services. So these are example of services that I talked about earlier, that you can have multiple services in a topology. So in this topology, we have we have services like Node, Job Tracker, Web HDFS, and you can see these are the URLs. So right now, this is just a you can have additional parameters and configurations based on the topology. So you can have you can specify the replay buffer size. So in case, I believe this is in MBs, this is the buffer size of the data. So initial how much buffer not. So basically, this is the buffer size for the payload. So when you make a request, if you have a bigger request, you need more buffer size. So that's the idea behind this. And yeah, these are simple services, but we also support HA, which is high availability. So in cases like Hive, you could have multiple URLs, multiple endpoints. So what Knox will do is, and this is all configurable, you can load balance them. So you can load balance between multiple instances. We also have sticky session. So a session can be specifically for services like Hive, which are not, which needs session affinity. You need to have you need a request or a session to go to a particular instance. So in that case, you need sticky sessions to be on. But in cases of services which are not which don't need session stickiness, you don't have to use that. So those are some of the additional configs available in Knox that we can configure. But yeah, that's an example of a topology, and every topology, this service definition has a reference to the service role name, and this is defined in the service definition. So the service definition is about which this config is a config that tells Knox how to proxy a specific service. So in this case, Atlas. So in the topology, you define the endpoint of, you tell Knox how to get to that service. But in service definitions, you tell Knox how to process the request, like how to proxy a request. And then you can add additional policies, like what authentication you want to use and what authorization you want to use. And all those configuration settings can be added here. And then all the different rules can be added. So yeah, that is a service definition. Let's see, there were a bunch of questions.
Yeah, Sandeep, we have some questions in chat. I hope you can see them.
Yeah, I can.
Okay.
Yeah, Lawrence is also a committer. So he's part of the Knox.
Oh, yeah.
He's also.
Yeah, Larry is actually the founding member of Knox.
Yes.
So he and Kevin, they started Knox. So yeah, it's another access to the time that I was showing the browsing using SSO. Yeah, so yeah, you can get access to the Knox using your single sign-on, and you don't have to have any other credentials. So. Yeah. Okay. Cool. That's just a discussion there. Any other? Let me go back to my presentation.
So Sandeep, I have a question. So is this like the Knox developed first by Cloudera, and then it basically made as an open source, or basically like Cloudera is you see already existing?
It was developed by Hortonworks, but it was always open source. It was never closed source. So it's always open source. And one of the things we do is we make sure that any features that are developed, they go out first. So they are contributed in the community, they're discussed in the community, like this Webshell feature. So we have a detailed write-up on on our Knox wiki about how we are going to do this, and we ask for community inputs. Every major thing that happens, the first thing we do is we create a design doc. We have a kit. We create a design doc. Then we send an email out to the community, to the user and the dev group, asking for the inputs. And based on basically the community has a chance to critique. But everything that is done, all the features that are done, they're done in the open. So hope that answers the question.
Yeah, sure. Thanks.
And these are just references, Knox website where you can find the user guide, dev guide, project information, all the releases, all the releases. I should have included GitHub info there, but easy to find GitHub project for Knox. And blog, we try to keep the blog updated with tutorials, examples, and how-tos, and things that we, edge case scenarios that we bump into, which there are so many, but don't go into the documentation because, not everything can go into the documentation. So blog is a good supplement for understanding, or if you want to develop a service, or if you want to develop a plugin, blog would be a good way of starting out, because it has detailed instructions and walkthrough instructions on how to do things. And then we have mailing list, user mailing list, and dev mailing list. We are always looking for contributors and contributors to contribute to the Apache community. Recently, we got a lot of people contributing, some from all different places. I should have, I tried to get stats from GitHub, but they changed the UI and I couldn't get all the detailed stats. So apologies for that. But if you look at the Knox repo, you can see the stats there, the mean stats, and see the activity. It's pretty easy to reach us. If you have any questions related to how to use Knox or how to develop services, plugins, etc. for Knox, feel free to ask us on the user and dev list. We are also active on Stack Overflow. So any questions that gets asked on Stack Overflow, generally, I try to answer it within 24 hours. But Stack Overflow is just slow because I get daily notifications for some reason. If the question is asked, the mailing list is the best way to get to us to ask questions. Any questions or any topics you want me to look at or dive into, I'd be happy to answer. No questions? That was easy.
Yeah, looks like a lot of discussion. Guys, please feel free to ask if you have anything. Okay, no worries. So this session is also recorded, so we will post the recording at LinkedIn and at Insight as well. We do have Abhishek.
Yeah, so Abhishek, there's yes, you can. How can you add a service to Knox? We have details on how to add service to Knox in the Knox wiki. Let me actually share that with you. Yeah. Go. So you go to Knox, we have a wiki there, and in the wiki, So we have Hadoop. This is an example of adding a buddy service. This is old, but we also have how-tos on how to add the different services. But basically, you can see there's a whole bunch of different places where you can add. I believe this adding a new service to an existing cluster. This is showing where I'm by add a service to Apache Knox. So this is an example of adding a service to Apache Knox. But this is an older wiki, but it's still just an older write-up, but it still covers the basics of how you do it. And this, for a simple service like this, it just works. Actually, I still use this weather service for testing the Knox releases. So this is an example of how you would do how you would add a service to Apache Knox. Let me put this in chat. Any default services? No. Yes, we have. And yes, we do have. Does Knox support course? Yes, Knox support. Yes, access. Yes. By default, Knox does that. So, by default, course is on, so you won't be able to get around it. But I believe there is some config. But yeah, by default, course is on. And why Kerberos is a mandatory requirement? Knox is actually not. Kerberos is not mandatory for Knox. You do not have to use Kerberos. Knox just makes Kerberos easy. But Kerberos is just one of the authentication providers supported by Knox. Knox supports SAML. Knox supports PAM authentication, your LDAP, it supports OIDC, we support, there's a whole bunch of, you can use Okta, you can use, basically all the authentication providers that we know of, Knox supports it.
Well, so Sandeep, I think they are talking about trusted proxies. So Kerberos, just like the XML-based descriptors and configuration, are all part of the DNA of the Hadoop ecosystem. So Knox requires Kerberos on the back end when it's talking to the back end services, because secure clusters require Kerberos in the Hadoop ecosystem. Now, Knox fills the role of a proxy user or a trusted proxy in this ecosystem. And what that allows such an application to do is issue requests to other services on behalf of other users. So users that are allowed to do that need to be fully trusted, and that requires strong authentication, which in the Hadoop world means Kerberos. So yes, Knox requires Kerberos to be enabled so that when we proxy or dispatch a request to a backend service, we do so after all strong authentication with Kerberos, and then we can issue a DUAS that the backend service can accept and actually execute the request as the DUAS user. Now the front door of Knox, and this was one of the primary reasons Knox was created in the first place, can be changed to be much more, HTTP client friendly. So username and password, SAML, whatever, just as Sandeep was saying. But the requirement for Kerberos for trusted proxies or proxy users is not just a Knox requirement, it's a Hadoop ecosystem requirement.
Okay, cool. Well, thank you so much. It was fun. discussing Knox with you. And yeah, you know how to find us. If you have any questions, send us an email on the mailing list, and we'll try to answer all the questions there.